So now we will lab how process switching is working, how fast switching is working, and how CEF is working. And I will show you in the lab that how this technology and all these stable as well. So we're gonna use a small topology. Let me show you this one. We will get three router, R1, R2 and R3. R1 is connected 12.1 and this one is 12.2. This is 23.2 and 23.3, and we will create some loop back interfaces as well for test purpose. So let's go to ENCORE, and I need three router. So take these router number of 3 and just type R, okay, and icon is okay. So now I have a R1, R3 and R2. Right click and say auto align, so it will make them align. Now connect this one to fast Ethernet 0/0 and 0/0, and connect this one to 0/0. Here we have 0/1 and here is 0, and now select and start these devices. Okay, I can use a script as well to configure them, because our main purpose is not to configure the router, because we need to assign the IP, by the way. So let me on these devices, and then I will copy paste the command. You can do the same thing as well if you want, either if you can configure yourself. So let me go there, 192.168.12.0. That's the subnet we are using between R1 and R2. Okay, why means 1 to 2, so that's why 1 2, 192.168.1 this is 1 and this is 2. Here router 2 to router 3, so I will change this one to 2 to 3. Okay, and this one is 2 and this is 23.2. and also I need to create two logical interfaces. We can create as many we want. So one of them will be 3.3.3 with 24, another one is 3.3.3.3.3 and 3.3 with 24 subnet mask. For test purpose we need something to connect here. Okay, so let me copy and paste the script as better to save the time. Okay, and let me go to CCNP, new enterprise and lab. There should be CF lab, I believe it should be, yeah, CF fast processing. Why I'm using this one? Because it will save our time to configure R1 IP. I will show you here. So in R1 I will go to enable mode, then I will go to configuration, I will change the host name, I will go to interface 0/0, I will assign 12.1 IP, no shutdown, and I will create a default route. So save the time, copy and type here no. Okay, and also in R2 type no. Okay, and R3 type no, and control Q to clear the screen. Okay, and paste. Okay, and let me type do right to save it as well. So basically I change the name to R1, I go to interface and configure this IP and default route to send everything to this router. Okay, and R2, what I need to do, I have two interfaces. 0/0 is connected this one 12.2, and the other one is, let me see the interface is correct, yeah, 0/1, and 0/1 I have 23.2, and I will configure 3.3 and default route this one, because in R3 there are two route extra. So R2 and paste, done, and do right. For new student, old student, they know what I'm writing. So if they don't know, you can ask me the question, okay, so that I can type myself. And R3, basically I need to go to fast Ethernet 23 IP, no shutdown, and I need to create loopback for test purpose 3.3 and 3.3, and default route to give everything to R2. Okay, and here is this, the basic configuration. Do right means save the changes. Okay, now okay, let me, okay, and R3. Now let me test I can reach to R3 or not. I don't need this one now. Now rest of the thing I will show you, which is our main topic. So let me drag this one to here and see from here. Okay, so from R1 let me ping one time 23.3. that communication is there or not? Okay, yes, it's working. So basically from R1 to R3 I'm reachable. Just for test purpose I check it. Now coming to our main topic. Now in new routers CEF is enabled already. How I know? If I type show IP CEF, look at the same routing table is there in R1. For 00 they said default route I will give everything to this one. And 00 I will receive. Receive means I can receive the traffic for 00. 00 means default. 192.168.12.0 they say this is my attach interface 12. So yes, it's true. 12.1 is this one. So this is attach. They say I can receive the traffic for 12.0 and 12.1. 12.1 is this interface IP and 12.0 is the subnet. And they say if a traffic came for 12.2, which is R2 IP, this one, I will forward to 12.2 and I can receive for broadcast traffic as well. And I can receive, multicast will be dropped. They say I will drop the multicast. Forget about multicast, we will do later in the course. And multicast I will receive and broadcast I will receive. This is the hardware routing table, which we call them CF table. Either we call them FIB table. This is FIB table. Let me go to the same table, show IP route. This is software table, but with less detail. They say I have connected interface, this one, and this is the default route. But hardware address is in more detail. That's why it's a preferred way. And also it's faster. So this is called RIP table, either routing table. RIP table, routing information base. This is routing information base table. This is FIB table. This is CF table, hardware table. This is software table. This is routing table. This is hardware table. Clear? For the same purpose. Now for software we have show IPR to show you layer 3 device to layer 2 detail. For hardware we have show adjacency detail. Right now we don't have anything. This one is software layer 2 table and this one is hardware table for the same purpose. Okay, so these things are clear to you. Yeah, it's come up now. Yeah, because this record is here, so it definitely has to be here. Okay, one thing I forgot. Why not let's change the MAC addresses so it will be easy for us to understand. We can change temporary, yeah. So let me go to fast Ethernet 0/0 and I can change the MAC address and let's say 123.4.123.4.111. So that's the MAC address of R1 interface. Just to understand them properly, that's why I changed them. Now let's go to R2. R2 has two interfaces. Interface fast Ethernet 0/0, MAC address 123.4.123.4 and 222. And there is another interface 0/1 and let's change the MAC address to 444. Okay, and the last router is just for the sake of understanding, otherwise no need to do this one. And fast Ethernet 0/0 R3 123.4.123.4 and 333. Okay, done. This is the simple thing to understand them properly. Okay, so where I was, so okay, so now you know these tables. Yeah, let me go back to show you. First one is FIB table, forwarding information base. It's a hardware address, and how we can see this one, if you type show IP CF, this the FIB table and hardware table. Now adjacency table, so show adjacency detail. This the layer 2 to layer 3 detail, which they keep. Like in software, we have show IP ARP. So this is the table. It will come up after a while. Clear two table. These two table exist in hardware. Done? Yeah, it's come up now. Now another thing which I told you about RIP table. So basically RIP table is nothing. When you type a command show IP route, this is called RIP table. Don't confuse RIP and FIB table and RIB table. So RIB table is routing table and FIB table is also a table but in hardware. Clear? So table is clear to you now. Now let's come to our main target. So we will do opposite. First we will not do process switching. We will start from CEF. CEF say that every packet has to go through hardware address, hardware table, and it will never touch a CPU. It's true? Let's see. In our topology, we have R2. Let me go to the middle router and type debug IP packet. I told them that anything which hitting your CPU and software and operating system, show me that IP packet. Whatever is going behind the scene, show me that packet. We call them debug IP packet. Whatever is going on behind the scene, which we cannot see. Now I enable them to show me. So I give instruction to R2 that any traffic is passing through your software, show me. So now let's go to R1 and ping R3. So I type 192.168.23.3. 5 times I ping and R2 say no, none of the packet is passed by software. I say maybe you are wrong, let me resend. R2 say no, none of the packet is going. Why? Because whatever I'm sending through hardware, and debug IP packet will show me those packets which hitting the CPU. So because of, if I say show IP interface fast Ethernet 0/0, so by default CEF is enabled. If I type this command, there is IPCF switching is enabled. They say because IPCF is enabled, I will send all the packet to hardware address. Show IPCF. Show IPCF, this table. They say I will use this table and will forward the packet through hardware fastly. Now you will say how you can prove this. When I show you the other two, so it will be proof to you that yes, it was using CEF. It was using hardware. Right now I know. You say how you can say that the packet is not going through. So I know you are true up to this point. So again let me send the packet to R3 which is passing through R2. But R2 not complain anything. They say nothing is going. Still debug is on. Okay, now it will be clear to you. Right now, all three routers are using CEF. How we know? So let me go to R3 as well and show you here as well. Show interface fast Ethernet 0/0 and let me make them filter switch. Switch SW show IP interface. Show IP interface. Sorry, here is. They say IP. No, sorry, flow. We will come a bit later. This one. They say that on my interface CEF is enabled, so we will use hardware table to forward the traffic. And where is hardware table? Show IPCF. This the table. Okay, great. Now it will be clear to you when we test this one. These two. So did you see any packet hit the CPU? No. First packet I sent, even I sent 15 packet. Again I'm sending 20 packet I send. None of them touch the CPU. All of them go through FIB and agency table. How they go? Let's check out. If I go to R1 and say show agency detail, here it will show me the MAC addresses because I changed the MAC addresses. So I give them, I think so, 11 and 33 and 22. So let's see, it will show me a bit later. Yeah, because this the receiving this one. Look at now. This the destination MAC address, and this the MAC address of R2, and this is the MAC address up to this point is in R1. You know, show IP interface 0/0. Sorry, show without IP to show you the MAC address. Here is this the one I change it. So they say this the source MAC address. The second one is the source MAC address, and this the destination MAC address, like a show ARP, and this the ether type. You know, the IPv4 packet, we call them 0800. Okay, so it means it's working through hardware. The packet is going through hardware. That's why it's not showing me anything here in debug when I'm pinging something. So nothing is showing here. Now let's disable CEF. So how we can disable? So let's go to and say no IP CEF. I don't need hardware address. And the same thing I will copy here and paste here. I will say no IP CEF. I don't need CEF. Done. And R1 and R2 I disable them. How we know? So we can check show IP interface fast Ethernet 0/0 and section switch. Here you will see that IPCF is disabled. Let's check out here as well in R2. Enter. They say that somebody disabled IPCF. Before it was enabled. I enable here, I think so. Here is before it was where I show you before. Here is IPCF was enabled. Now I disable them. So when you disable CF, now which thing is enabled? Now coming to the second part. CF, sorry, fast switching. Now what fast switching say? Fast switching say that first packet has to touch the CPU, then rest of the packet will go through hardware. This was the story of fast switching, yeah. And they say how I keep the record. They say I will keep the record in cache, a small temporary memory. So now let's check out. Now let's send a packet. So fast switching is enabled, by the way. Look at this one. Sorry, this one. Fast switching is enabled and CF is disabled now. Let's send the packet again. Same story. Let me ping them. Now you will see first two packet here. Look at. Before it was not showing. Now they show me two packet. One for go from this side, one for return. And what they hit? They hit the RIP table. What was RIP table? Software table. CPU. They say I hit the, but it will not hit again. Send again. No. Because in fast switching, first packet for the same source will be hit once, which is hit it already. If I send again and again 5 packet again, no, nothing goes wrong. But how can I prove now? So let me give a space because we have a new destination 33. So let's ping 33 first time instead of 23. So what do you think? 2 packet will be there now again. Ping, and now let's see. Look at now. It say I will hit the first packet will hit RIP table, routing information table, because you are using fast switching technology and you disable CF. So fast switching say that whenever you go first time to any destination, so it will go through CPU. Next time when you go to the same destination, it will go through hardware. And that's why first time I go to 333 through CPU. But when I hitting again, let me repeat them 1000 times. It will never touch them again. It's the same. Let me clear this one because debug is on. But let me stop this one. Control Shift 6. Let's hit 333. There is a 33 as well. What do you think? Who gonna tell me that what will be show in R2? If you understand, so definitely you have to answer me correctly. If I ping 33, 33, 33 and 33, what gonna show me in R2? Anybody?
First packet would there, sir, R2.
Yes. Okay. So it means you understand. So if I enter, now you will see first packet. Look at now. Which hitting RIB table. And RIB table is nothing but a routing table. And routing table is nothing but a software. And software is nothing but a CPU. Because now they are using, why it's not hitting second time when I'm pinging? Because show IP route cache. It's route cache or route something? Router cache, sorry. Router. It was a command show IP route. There is a cache, some command. Let me see cache or cache. I forgot the command. Yeah, show IP cache. I remember now. Show IP cache. Here they keep the record. Now they say that I have 3 entry and table, 3 cache. Somebody went first time to 33, then 33 and then 12.1. So I have this record. So when they go next time, it will not hit the CPU. That's why when I'm pinging again, it's not hitting. Yeah, if I have a new destination here, right now I don't have any other. Then because they don't have a record here, so what will happen? Then it will hit the CPU. This the command to check the fast switching table cache, which I told you they will keep in cache. That's the fast switching cache. You see this one? This table. Now they have the record for 3. So if I go to 33 or whatever, it's been done once. Now it will never hit the CPU until if it is a new destination. So first packet will hit the CPU. Then rest will go to hardware. Done. Now coming to the old technology, which was hitting, every packet was hit by CPU, and we call them process switching. But how we can do that one? So for that purpose, sorry, I need Control Shift 6. I need to disable fast switching as well. I already disabled CEF. So for that I need to go to interface 0/0, which is the interface of R1, this one. Let me make this R1 here. R1 here. Okay. And what I need to type? I need to type no IP CF. Sorry, this was I think so. Yes. No, sorry. No IP cache something. Forgot the command sometime. No IP route cache. Oh, sorry, I'm not in the interface. Sorry, I thought why it's not working. So I will say no IP route cache. So I say disable fast switching and interface. But here I have also 2 interfaces. So 0/0 I will disable route cache, and I have interface 0/1 and R2 2 interfaces and disable. CF is already disabled. Now I disable fast switching as well. How I know it's disabled? So the command is show IP interface fast Ethernet 0/0 and section switch. Now they say see if it somebody disable it, and fast switching is also disabled by someone. And if I go back, so fast switching was enabled before. IP fast switching was enabled when we were testing. Now I disable this one as well. And R2, let's verify here. It's better to verify. So I will say Control-Shift-6. Just wait a minute. Now it's stuck. Because when you press Control-Shift-6 in real environment, so it will stop, but here in simulation it will not work. So I need to wait because I mistyped something. Instead of show, I type show something in this mode. So when you type in this mode, so it will search. You know, either you need to disable lookup. So now it's looking up, so I just need to wait. I don't have any other option. If it is a GNS3, then you can disable them by Control-Shift-6 and also in real environment. But unfortunately here it will not work. I need to wait. It's searching for, I typed 2 times something wrong. SOW and this one. So if you get this issue, you need to wait. That's the only thing you need to do. In real, it's okay. Control-Shift-6, so you can be like a Control-R-Delete in window. So it's stuck. I don't have any other thing to do it. So you know it's disabled now. So we gonna test the last thing, which is process switching. And process switching say that every packet has to touch the CPU. So if I ping from R1 to R3, every packet will show in R2. And that's what we want to see. Okay, so let me go to R2. What the hell is this one? Okay, so debug is already enabled now. And let me verify, by the way. Show interface fast Ethernet 0/0 section switch. Show IP interface, by the way. And let me remove S from here. So now you can see IP switching is disabled. Definitely disable another interface as well. It's better to check out rather than to take a risk. So it's disabled now. Okay, so now let's test. So if I ping from here the same R3, okay, if I, so it by default 5 packet, yeah, in R2 it will show me 10 packet because 5 are written. Check, and now let's see, look at 10 packet, because now we are using process switching, which hitting every packet hitting CPU. There is no concept of hardware. Done. Let me give a space and send again the packet. 5 packet and 10 packet return. Every packet is hitting RIB, routing information base, software, CPU. Because CEF is disabled, fast switching is disabled, old technology is enabled. Now you get the idea. So process switching is a technology. In old days, router were using this technology to process every packet by CPU and head by CPU, which I show you and now is hitting. Then Cisco introduced an fast switching. They say, why not? First packet has to touch the CPU and rest of them has to be in cache, a small table to keep the record. So when next time it's going to the same source and destination, we will use the hardware. Then they say, okay, but for every new destination, we need to hit the CPU. So they say the latest technology is a CEF, Cisco Express Forwarding. Why not copy the table from CPU to hardware? And we will not touch the CPU. Every time the packet is coming, we already have a record in FIB table rather than in RIP table. And every packet will go to FIB. That's why I show this one at the beginning. So all the packet was going through R2, but none of them was showing here the packet, which I enabled debug. I hope so you understand these 3 technology, okay, that how the router working and how they forwarding the traffic.